Today we will see what are containers, what are virtual machines, how our virtual machines are different from containers. Before cloud computing days, every individual user or organization used to buy their own computer, own hardware, and using their hardware, they will install their own operating system. So once the hardware and operating system is installed, we can call it as a server, and this server will be connected to a public network. Inside this server, the code will be deployed with the help of the web server or app server, and there will be a public address assigned to the web server. This public address is mapped to the DNS using the same domain name. The user can access the web application. But with the cloud computing concept, we don't need to buy a own server physically, and we can buy a server virtually from the cloud providers, and the cloud providers behind the scenes, they will give us a virtual machine. Here the virtual machine can't be seen physically. We can access it virtually through the web or internet. Like generally it consisting of a infrastructure is nothing but physical hardware. It is provided by the cloud provider like AWS, Azure, or GCP or any other cloud providers. We have a hypervisor software on top of the uh, infrastructure. Like using the hypervisor software, the same physical hardware, we can create a multiple VMs. Like suppose if the server RAM is around 32 GB and of SSD of something like 4 TB or 6 TB, we can divide it into a specific partitions. Like example, like first virtual machines can have like 8 GB RAM of memory and 1 TB of memory, and second virtual machines can also have like 8 GB RAM and 1 TB of memory, and third virtual machines can have remaining 16 GB and the remaining 4 TB of uh, storage. So inside the VM, we can install our own guest operating system, uh, and other VMs also we can uh, install our own operating systems. Like VM1 can give to one user and VM2 can give to another user and so on. Suppose like we have a scenario like we have a microservices. Consider app A is a one microservice and app B is another microservice. So for app A, I may need to install a few softwares like Java, Python, etc. We may need some web server or app server. So all the required binaries we have to manually install in the VM1. Similarly, we need to do for VM2 also for all the required binaries and libraries for the app B. So after all the binaries and libraries uh, are installed, then only we can uh, use our app A and app B microservices. Once the deployment is completed, then the microservices can be accessed using the public IP address. This public IP address is similarly given by the cloud providers for each VM, like how we previously a unique IP address was given to our server. Similarly, like a IP address will be given to the each virtual machine from the cloud providers. The same IP address is mapped to the DNS, and with the DNS we can use our own microservices. Why can't we deploy all our microservices, all our apps in a same virtual machine? We may have the doubt because we may have a different software versions for each uh, app or service we may consider. Like for app A, we may use like Java 8 version. For app B, we may use like Java 17 or Java 21 version. Um, like we may face some problems if we deploy in the same VM. So if we need to restart the VM, both the virtual machines need to be down for a particular amount of time. And there will be a scalability issue also. Suppose if you want more number of uh, API instances, if we get more traffic to API, then we may need to increase our API service. With the VM concept, it will take some time to install the guest OS and other dependencies and libraries. So, better to choose the containers here in this scenario. Like, what is a container? As we discussed it previously, like they will share this. They will also have the same architecture. Like they will have the infrastructure, physical infrastructure, and based on the physical hardware, they will install a specific host operating system. This host operating system is shared by all the microservices available in the container. But while coming to the virtual machines, we need to install a specific operating system on each virtual machine. So when the guest OS is not there for containers, so the containers will be a lightweight. The main advantages are creating and destroying the containers and restarting the containers will take only few seconds. The containers are nothing but are like a packed components where all the required dependencies and packages are dependencies and libraries are packed together. Like if we consider like API is one container, then it is including all the dependencies and libraries which are required for API. So we no need to worry about it. So all of them will be clubbed together and it will be available inside a container. We call it as a container. So when we are trying to create a new container inside another server or another environment, we no need to install the dependencies like Java or any others. Or if you consider like microservice one is of Java and Spring Boot developed service, so we may need to install Java and Spring Boot libraries. So if we develop only one container, the same thing can be used in other environments also. We can just take the packaged component of one container to some other environment and convert the package to a container with a single command. Because the containers are lightweight and deployment is easy, and every container will have its own network resources and own memory and own storage, it is very easy for us to use the containers. The main difference is the containers don't need a guest OS hypervisor to assign the resources. Instead, they will use the container engine like Docker.